So in the previous examples, we found all the factors when we were given one or two factors, but now what happens when we aren't given any factors? And what we first need to learn about is the rational zero theorem. And what it does is it helps us figure out what could possibly be the zeros given the polynomial, and we use that to find the actual zeros. So really, we want to use these to find the possible zeros. And we use an educated guess to know which one to start trying. So we're trying to find the possible zeros. All right, so let's take a look. So here, and you'll notice that we are looking at the factors of the constant over the factors of the leading coefficient. So if we look at this first example, the 6 is going to be our constant, and the leading coefficient here is, in this case, it is 1. So our P over Q values, P are just our factors of our constant, Q are the factors of the leading coefficient. We're going to look at what are the factors of 6. And I want you to recognize that you could have like 1 times 6, or you could have negative 1 times 6. So if you thought the factors of 6 are 1 and 6 and 2 and 3, you're absolutely correct. But we also need to include a plus minus. So our factors of 6 could be plus or minus 1. We could also have plus or minus 2, plus or minus 3, or plus or minus 6. Those are all factors of 6. And then the only factors of 1 are just plus or minus 1. And we can simplify this to just 1 over 1 is just going to be 1. 2 over 1 is going to be 2, and so on and so forth. So that these are our only factors of, possible zeros. And you notice this right here is 2 possible zeros, another 2, another 2, and another 2. So really we have 8 possible zeros for this particular polynomial. Now let's look at another one. This one, again, if we look here at our leading coefficients, it's not just 1. Our leading coefficient here is 3, and then our constant is negative 8. So let's see, if we're talking about our P over Q values, we first want to think about our factors of 8, which are really just 1, 2, 4, and 8. And remember, we want to put a plus and minus in front of each one of those possible factors. Now, if we're thinking of the factors of 3, it's just going to be plus or minus 1 and plus or minus 3. Now, you will need to simplify this. You can't just leave it like that. You can easily put each one of these numbers in the numerator over 1 because it's just going to give us itself. But we also have to put each one of those numbers in the numerator over 3. So you'd have plus or minus 1/3, plus or minus 2/3, plus or minus 4/3, and plus or minus 8/3. Whew, that's a lot of possibilities. Let's see how many possible zeros we have. 2, 4, 6, 8, 10, 12, 14. We have 16 possible zeros here. That's a lot. Okay, so let's talk about, once we know how many possible zeros, we can use those to start using synthetic division to try to figure out what the actual zeros are. So here in this example 5, we're given a polynomial and we've got to come up with all the possible rational zeros. Again, those are our P over Q. This one's easy because our leading coefficient is 1. So these are going to end up being our factors of 8 all over just plus or minus 1, which means our possible zeros are just going to be the same thing we have in our numerator. So now we actually have to use synthetic division to actually find what are the actual zeros. And in this case, you just want to start and be easy on yourself. You don't want to make it super complicated. And usually I'll start with 1. So I'm going to start with the possible zero of 1 and pull my coefficients. And it doesn't look like I'm missing any terms, so I can just pull my coefficients here. And we'll see if 1 is indeed a factor of this polynomial. So I'm going to pull down my 1 if you want to pause this and do your synthetic division and check back with me. So 1 did in fact end up being a factor or a zero of this polynomial because we got a 0 denominator. Now at this point, because we started with a polynomial that was to the 4th power, we now know that we can associate this with 1 power down, or x cubed. So we can go in and write our polynomial here and associate it with our x values. Now, I could see, if I look at that, there's no way I could do factor by grouping. So I may just want to see if I could do synthetic division again using all of these coefficients that I ended up with for my previous synthetic division. So usually if I have tried 1, I may then go try -1 and see if it works. So again, remember, I'm going to pull this into my resulting coefficients, and I'm going to do synthetic division. So do synthetic division and come back and check. Now, it happened to be that I guessed right here, and -1 was also a 0 of this polynomial. And so now, since I have done synthetic division for a second time, if I assign my x values here, remember I got to an x cubed. So now I've done synthetic division one more time, so I'm down at an x squared level. X squared plus 6x plus 8. And we're at a quadratic that we could possibly factor. And hopefully you see that we can factor this into x plus 4 times x plus 2. So if they ask me to find all of the zeros, we know that we have zeros at -1 and at 1. We found that. Now, if I look at these two factors right here, we have zeros at x equals -4 and x equals -2. So -4 and -2 are also zeros. They also ask us to write this as a linear factorization. All that means, they want us to write our polynomial g of x just as part of these factors. So if I have a 0 at x equals 1, my factor is going to be x minus 1. If I have a 0 at x equals -1, my factor will be x plus 1. And then I have these other two factors that I've already found at x plus 4 times x plus 2. Now, if I multiplied this all the way out, all of these factors together, I would end up with what I originally started with. Okay, so I want you all to practice this next problem and then come back and check your work. Okay, if you need to pause this to check your work, you can do that, but there are a couple of things that I want to point out. I usually, once I've determined what the possible zeros are, I'll usually start my synthetic division with 1, and then I may go to -1. You'll notice that once I find a factor, like here in this example right here, I took my resulting coefficients, and that's what I used to continue on with my synthetic division, because I found that 1 was an actual 0 or a factor. Now, when I ended up continuing to do synthetic division, when I tried -1, it didn't work. So I just kind of X'd through that and kept going. I don't erase it, I leave it. It may be helpful later on to see how close I was to actually getting that to be a 0. Now, in the second one, I did keep going, and 1 and -1 ended up being 0, so it made it easy, and I didn't have to try any other possible zeros. Okay, so now we found some rational answers. But what happens if you've used synthetic division, and maybe you've used more than one round of synthetic division, but what happens if you get to a quadratic you can't factor? How do you solve it? And I want you to remember back to first semester when we talked about other ways to solve quadratics. And we looked at using the square root formula, or excuse me, the square root method. And another way that we also solved quadratics was using the quadratic formula. So we're going to go through some examples here where you may need to use one or both of those, depending on the situation. So here, if we're taking a look at this example, we notice that our possible zeros are going to be, because our coefficient's 1, we're just dividing by plus or minus 1. So our possible zeros are plus or minus 1 and plus or minus 5. So I want to go through and try some synthetic division. We aren't missing any terms, so we don't have to use any placeholders. And as I go through synthetic division, I end up finding, I first tried 1, which is what I usually start with, and that did not indicate that that had a 0 remainder. So that's not a good option. So I'm going to go to my next standby. Again, I'm going to go back to my original equation because my previous attempt was not a factor. So here, when I do this, I do end up finding that -1 is a 0. And I'm left with a 1, a 0, and a -5. Now, at this point, I could keep going, but what I would say, we started out with a cubic. And so if I take these coefficients right here and write and assign x variables to them, I'm going to get x squared plus 0x minus 5, or just x squared minus 5. And I want you to ask yourself if you can factor that. And the answer is no. When we are factoring them, I know we usually don't say this, but what we're doing is setting that equal to 0 and solving for x. That's what we're doing using the zero product property. But here, if we have this equation, x squared minus 5 equals 0, we could use the square root method. We could add 5, well, let me first say this. Since this cannot be factored, we can add 5 to both sides of the equation. So we'd get x squared equals 5. And then if we want to solve for x, we're going to take the square root of both sides. And don't forget, when you take the square root of both sides, you are going to get plus or minus the square root of 5. And so here, our zeros are going to end up being, we had already found -1, and now we have plus or minus the square root of 5. All right, let's go through another example to demonstrate this. So here, I hope you recognize, first, if you're looking at your possible zeros, you've got plus or minus 1, plus or minus, plus or minus 2, plus or minus 4, plus or minus 7. Ooh, there are a lot. Plus or minus 14, and plus or minus 28. Now, I hope you recognize here that we do have some missing terms. So we would want to write this as x to the 4th plus 0x cubed minus 11x squared plus 0x plus 28. So don't forget to do that so that you make sure you put your placeholders when you do synthetic division. So I want you to do synthetic division until you find something that works. So pause and come back. So hopefully you got to this point. You found that 1 and -1 did not work, but this 0 of 2 does work. And because we started out with a 4th degree power, we can now assign a 3rd degree power. So we have x cubed plus 2x squared minus 7x minus 14. And when you write this out, I'm hopeful that you recognize that this ends up being something that you could factor by grouping. So we've got x squared times x plus 2, and then we can factor out a 7 out of our last two terms, and x plus 2. So we end up getting x plus 2 times x squared minus 7. Now we know that x plus 2 is a factor, right? We've already seen this. And now if we're trying to solve this quadratic, we know that can't be factored. But we could end up setting it equal to 0 and solving. And we end up seeing that we can solve this using the square root method. And so we end up finding that our other zeros are plus and minus the square root of 7. So all of our zeros here are going to be 2 and then plus or minus, not just 7, but the square root of 7. All right, we're going to do one last one. I want you to come up with the possible zeros and see if you can find a particular factor, and we'll circle back together. So you probably found that x equals 1 did not factor, but when you tried -1, it did come out with a 0 remainder. So we know that that's actually a factor of this polynomial. And we're left with this quadratic that hopefully you recognize, because this last term is positive, that you cannot factor. And so one thing we can do is set this equal to 0 and use the quadratic formula. So why don't you do that and check back with the answer. So here we were able to use the quadratic formula to solve for x, and we end up getting that our other zeros are 3 plus or minus the square root of 2. Remember, be very careful when you are simplifying as you use the quadratic formula. And you'll notice in what we've done so far, you can use synthetic division to help you start and then get to a point that you can either factor, use the square root method, or finally use the quadratic formula. Last video, we'll be talking about the sum and product theorem.